Greetings, Westmont Algebra 2 students. This is Mr. Earth here. And as per request, I thought I would make a video demonstrating an example problem of how you would use regression to solve a question. So here we go. Let's take a look at this one here. This is also up on Schooloop. It says, a store owner has determined that the number of customers she gets each month is related to how much time she airs television commercials in that month. Here is the data she's collected over the first 6 months of the year. In January, commercials for her store aired for a total of 50 minutes, and she had 2,260 customers. In February, she put on her commercials for 10 minutes and only had 460 customers. In March, she did 40 minutes of commercials and had 2,410 customers. April was 60 minutes of commercials with 1,210 customers. May, 20 minutes of commercials and also 1,210 customers. June, 30 minutes of commercials, 1,960 customers. So we've got all this data here. So just to make sure we understand what's going on, so every month she airs a certain amount of time of commercials, and then she sees how many customers she gets that month. Here's what the question asks us to do. It says, find a regression function which best fits this data. Use this function as a mathematical model to predict the most number of customers she could have at her store in any given month. Also, recommend to the store owner how many minutes she could air next month in order to achieve that highest number of customers. In what way is the value predicted by our model for the highest number of customers not perfectly accurate? Do you think this function still models the real world well when the number of commercial minutes gets large, say over 70 minutes per month? Why or why not? Okay, so I was just reading the question. Let's actually do some mathematics and answer these questions. So the first thing we're supposed to do here, it says find a regression function which best fits this data. So the first thing we need to decide for a function is what's our input and what's our output. So typically the input is your independent variable, and that goes on the horizontal axis, the x-axis. And then you've got a dependent variable which depends on the other variable, and typically that goes on the vertical axis, usually denoted by y. So we've got two different things going on here. We've got how many minutes of airtime our commercials get, and then we've got how many customers we get each month. So the first thing we have to decide is what's the x and what's the y, sort of what's controlling what. And I think in this situation, and it's different for every problem, but in this situation it's the independent variable. What we get to kind of control and decide is the number of minutes we're going to air a commercial. So that's going to be our x. And the dependent variable that sort of depends on that is how many customers we get. So we don't have control over the number of customers. That's sort of an outcome, a consequence of the number of minutes. So that's what we're going to put on the y. So each of these situations every month is going to become a point on a graph. So it's going to be x comma y. It's going to be the number of minutes of the commercials for the month on the x and how many customers you got for the y. So let's go ahead and put that over here into Geogebra. You can also do this on your calculator with L1 and L2, but I know not everyone has a graphing calculator, so I'm going to do it on Geogebra because I know everyone has access to that. So let me widen up the screen a bit. Alrighty, so the first thing you should do when making a graph is actually show the reader what your axes represent. So as we were discussing before, the x-axis, this horizontal thing right here, is going to represent the amount of commercial time. So let's go ahead and label that. So I'm going to go ahead and go up here to where it says ABC up at the top right here. Click it. And if you'll notice, it gives me options here. I'm just going to put it on text. This is the very first default one. And just kind of click anywhere because we can move it later. And this is going to end up being the label for our x-axis. And it's supposed to be the monthly commercial time. And after you have the label, it's traditional that in parentheses right after it, you put your units. So I'm actually going to require that you put the units here because we have to know, what do these numbers are? But this 11, 12, 13. So is that hours, minutes, seconds? So in this case, it's minutes. So I'm going ahead and typing in here and just click OK. And so there we go. We have this, and now we can move this around anywhere we want. So I'll put it right here. And actually, I'm going to enlarge it a little bit. So if you want to see how to enlarge it, I'm just going to right-click, or if you're in the Chromebook, you have to do a two-fingered click. Go to Object Properties, go to Text here on this tab, and let's change it from small to large. Just make it a little bit bigger. click OK. Oh, guess you got to close the box there. All right, awesome. So here we go. Now, one thing we noticed is the default here seems to be going from 0 to 16, but if you remember the numbers that we had, they were a lot bigger than that. So if, in fact, I were to actually start putting my points on now, you're going to see that we wouldn't see them because they'd be off the graph, because our graph is only looking from 0 to 16, and we never actually had any time that was that small. Actually, we did have one time in February. We only did 10 minutes. So that one you'd actually might be able to see. But all the rest of them, like the 20, 30, 40 minutes, they'd be way off here to the right. We wouldn't be able to see them. So I'm going to go ahead and adjust this x-axis right here. So remember to adjust the axes. You click on here. And it's actually the very first option, Move Graphics View. So if you grab on the white part, you can move the entire axis around. Notice the label moves with it. Kind of nice little feature. But if you actually hover right over the x-axis, you get that little double arrow thing, and it says in red x-axis there. And when you pull towards the origin, you can zoom in and zoom out, and it only affects the x. So let's go a little more. Let's have about right there. So I'm going from 0 to 70. So I know I don't get as quite as low as 0 or quite as high as 70, but I like to have a little bit more than the stuff we're actually plotting. So, okay, so we've got our x-axis set up, and we've got our label. I'm going to recenter that label a little bit. There we go. All right, well, let's also do the same thing for the y-axis. So what does our y-axis represent? Well, it's sort of how much business we're doing that month. So I'm going to go over here, click text, and I'm going to say it's our monthly business. And how are we measuring how much monthly business we're doing? We're talking about like dollars of profit or whatever? No, we're actually talking about customers. So in parentheses, our units are going to be customers. It's telling me how many customers we got that month. And that's going to be the label for the y-axis. So I click OK. And again, we can make that a little bit bigger. So I'm going to right-click, Object Properties, go to large. Okay. Now, you don't have to do this next part, but I think it makes it look better, because right now, it kind of doesn't quite fit on the screen the way we have it. And it's traditional that for the horizontal axis, you put the label horizontally, but for the vertical, the y-axis, you can put it vertically. So there's a little trick that you can do that will make this appear vertical. Again, you don't have to do this, so if this confuses you, you can ignore it. But there's actually a command that Geogebra knows called RotateText. So I'm going to go over here to the input. Oh, one thing I should point out, if you hover over here, it says that the name of your text is text2. This one right here is text1. This one is text2. So if I had done a third one, it'd be called text3, and so forth. So the reason why it's important is when you rotate text, you have to tell it what text you want to rotate. In this case, we want to rotate text2. We want to leave text1 alone. So I'm going to go over here to input. I'm going to type the command rotate text. It's all as one word. And then in parentheses, you say what text you want to rotate. It's going to be text2. Not text, T-E-X-T, 2. And then you have to tell it how many degrees you want to rotate it. We want to rotate by 10 degrees, 20 degrees. Well, we want it rotated all the way to be vertical, so that's a 90-degree rotation. So I'm going to type 90. But it turns out you also have to tell it that it's degrees. So how do you get the degree symbol? Well, right over here, right after this big long input box, there's this symbol that's actually the Greek letter alpha, but it won't type an alpha. It actually brings up this whole table of symbols right here. And if you'll notice, this one right here, if you hover over it, says degree, that's the degree symbol. So I click it, and notice the little degree symbols there. So it's rotate text, parentheses, text2, because that's the label for this monthly business customers thing, comma, 90 degrees, then you close the parentheses. It should automatically be closed, actually, because when you type the open parentheses, it automatically does the closed one. And then when you're done, push enter. Aha! There we go. It appeared right there. Now, that's not where we want it. We actually want it up here somewhere. So I'm going to drag it up here. Notice it appeared tiny. I think the default is to appear as small text. So it really didn't do any good to enlarge this one. This is the one I should have enlarged. So right-click, Object, Text Size Large. Cool. So now it's nice and large. Now, you might say, but wait, we still have the original horizontal one here. We don't want that. So there's a couple of things you can do. Probably the easiest thing to do is right-click, and if you'll notice right here, it says Show Object, and that's turned on. So click that off. Boom. So it turns out it's still there. It's just not visible. So now we have to think about what about the scale for our y? Because right now, the y, which represents our number of customers, is only going up to 6. And that's way too small. So just to kind of show you what would happen here if we left it like this, is I will actually enter in our first data point, which is for January. So I'm going to go down to input. So I'm clicking in the input box. I'm going to type capital J-A-N for January. Remember, you want to start with capital letters for points. Equals, I'm going to type parentheses. It's an ordered pair. I got to put in the coordinates now. So remember, the first coordinate is the x, which is the amount of minutes that our commercials aired for that month in January. And in January, I believe it was 50. So I'm going to type in 50, comma, and now comes the y-coordinate. Remember, the second number of the coordinates is the y-coordinate. In this case, our y-coordinate represents how much business we did in terms of customers. And back in the original problem, it was 2,260 customers in January. So I'm going to type 2260. Don't put a comma for the 2,260. So the comma just separates the x and y. There's no comma for the thousands. All right, so there we go. There's January. I push enter. And it says, hey, you have over on this side, on the algebra side, it says, yes, you have a point called January at 50, 2,260. So I go across here to the x, I see 50, but I don't see a point here. That's because the y is way too big for it. It's way, way up here off the screen. So I'm going to have to adjust my y-axis. So to adjust it, you go back here to the little crosshairs. And you know what? I'm actually going to move this down a little bit too, the whole thing down. And I'm going to hover over the y, so notice it says in green y-axis, and I'm moving it down. Hey, it moved my labels. That was kind of weird. Didn't expect that. So actually, I'm going to click on move and move this back to where we want it, and move this back to where we want it. But I'm still not nearly high enough, so let me go back here, click on y-axis, drag it down a whole lot more. Of course, I'm moving my other labels. I believe it's moving the labels because the position is based on the x and y coordinates, which I'm now changing around. But I still need to move some more. So let's see. Oh, hey, look, there's our January point, right where we thought it'd be, 50, 2,260, right there. So we don't need to go quite that zoomed in. There we go. So let me just again move my labels. And maybe move my whole graph down a little bit. Recenter these labels a little bit. I'm just fudging this. Oh, okay, I think that's plain good. I should point out that when you do this using the calculator, you don't actually get to label the points. Like with January, we call this January. So the points actually won't be labeled that way if you do it on the calculator. But Geogebra lets you actually put labels on points. So I'm going to put the rest of the points in. So I go back to input, and I type February with a capital F equals parentheses. So February we had only 10 minutes of commercials and 460 customers. Boom. So there's February. And I'm going to fast forward while I put in all the months. Actually, no, I'm not going to fast forward. I'll let you do it in real time. So March. And March was 40 minutes of commercials and 2,410. Let's get an idea of where we think that's going to show up, by the way. So March 40, so I would go over across 40 because the x-axis is commercial time. And then I have to go up 2,410, which is probably about right there where my cursor is. So let's push enter and see. Oh, I was a little bit too low. But okay, so there we go. So there's March. Put in April. So April was 60 minutes of commercials and 1,210 customers. So there's April. And May. May was 20 minutes aired of commercials and also 1,210 customers. So let's sort of think about that for a minute. So 20 minutes of commercials, so I go across on the x, the commercial axis for 20, and then up the exact same amount as April. So it should be totally in line with April, just way over here to the left. So it should be about right where my cursor is. All right, there it goes. So there's May. And then we've got one more month add, and that's June. So June was 30 minutes of commercials aired and 1,960 customers. All right, so there we go. So this is a scatter plot of how many customers we got based on the amount of commercials we aired that month. So, all right. Now, what's the next step? So if we go back to the question, it says, find a regression function that best fits this data. Now, it turns out there's lots of different models you can use. There's logistic models, there's logarithmic models, there's exponential models, there's sinusoidal models, but we haven't learned any of that stuff yet. At this stage, the only thing we know is polynomials. So we're going to have to use some sort of polynomial. So let me show you. This is where you would do the whole thing on the calculator with stats and calculate and linear regression. Scoot over. There's a command that does it in Geogebra. And here's the command. It's FitPoly. So you just type it as one word, no space, just FitPoly. So that means we're basically finding a polynomial of best fit. And then you put a parentheses, and then you put in the points. So the points we wanted to try to go through are January, February. The order actually doesn't matter. I'm just going to go in order. January, February, March. Oops, misspelled April there. April, May, June. Okay, so there's the points I want to go through. But it turns out that's not enough. If you try to hit enter now, it's going to give you an error. So what we actually need to do is do one more comma. And because we're fitting with a polynomial, you have to put in the degree of the polynomial you wanted to use. So let's say we're being kind of naive about this and we go, yeah, this looks like a straight line. I think all these points are collinear. So the degree of a straight line is 1. So I'm going to type in a 1 here. You're going to see that this isn't going to fit very well, but this is what I'm typing. Just to kind of recap, FitPoly, and then in parentheses you put the points, which are January, February, March, April, May, June, because each one of those months has two variables associated with it. There's the amount of times of commercials, the X, and also how many customers we got that month. So every point actually represents an ordered pair. So I put in those months, and then I say comma 1, and let's hit enter and see what we get. So over here it gives you the equation. Remember, f of x is kind of like saying y. So it's saying y is equal to 21x plus 850. So a slope of 21, a y-intercept of 850. Don't worry about how the program came up with these numbers. We will actually learn some manual ways to figure out these numbers. But at this stage, we're just going to let the computer do it for us. And to be honest, in reality, no one does it manually. It's just very long and tedious to do manually. You pretty much always use some sort of calculator or computational device to just tell you what it is. What's more important is, what does this represent? So this is the best straight line you can do that can come closest to all of these data points. And we can see it's actually not very good. So let's change it. I'm going to go up here, and rather than retyping everything, I'm just going to double click on here. And I'm going to change the degree. So since it doesn't look like a linear function is approximating our data points very well, let's use a parabola to try to do it. Next, let me cancel this, get this out of the way for a minute. It kind of looks reasonable that maybe a parabola might work, right? Because for a while it looks like, okay, we do a certain amount of commercial time and customers are going up, but at some point just the customers get too inundated with commercials, they start to ignore them, or maybe they're like, oh, this place, they're so desperate for commercials, let's not go there. I don't know what's going on, but what this data suggests is that for a while, more and more commercials, more time of commercials is good, and at some point you have overkill, and people are just saturated with the commercials too much, they just don't even look at them anymore, and you would have been better off not having like the 15, 60 minutes. It looks like you can actually do better with less amount of commercial time here, because notice in January and April, if all we had were those 2 data points, we wouldn't be able to see the pattern. But with 6 months of data points, you can kind of see, hey, maybe it looks like that's a parabola. So to do a parabola, that's formed by a quadratic function. And we know from class quadratic function is degree 2. So I'm going to come over here and do degree 2. So I'm changing that 1 to a 2. And let's see what we get. So I'll have to extend this window a little bit so we can actually see the full quadratic. So there we go, negative 2.25x squared plus 178.5x minus 1250. So that's like your capital A, capital B, capital C, your coefficients. There's the parabola it's making. It's okay. I mean, it's better than the straight line for sure, but I think we can do better. So this model's all right. It's kind of approximating what the real life data was, but let's just do a little bit more. Let's see what if instead of a quadratic, what if we used a cubic? What if we tried to do an Elvis graph here? So I'm going to change the degree to 3 and see what happens. Ah, that actually looks a lot better. So back when we had a parabola, the peak was sort of in the middle. It was nice and symmetric. But here we can see the peak is sort of slanted. It's off to the side. It's not exactly even. So, and it looks like this is a much better fit. And you might say, whoa, would we get an even better fit if we used a 4th degree equation or a 5th degree equation? Well, it turns out this is actually a perfect match, and you can't get better than perfect. Now, by the way, normally in real life, you're not going to get a perfect match. I gimmicked up these numbers, so it was a perfect match, just to make a point. But because it's a perfect match, you can't do better than perfect. You're like, well, what if we try? So right now, this is our equation for the cubic. Negative 0.05x cubed, that's like your capital A, plus 3x squared, that's your B, plus 20x, that's your C, plus 10, that's your D. All right, so, but let's try to use a 4th degree equation, so a quartic. So we're going to come over here, I'm going to double click, I'm going to say, hey, Geogebra, make me an equation with degree 4 that's somehow better than this. And let's see what it does. Looks the same. In fact, look at the equation right here. Here's the quote-unquote quartic. It put a 0 in front of the x to the 4th. So it's really just the same cubic wave. You can't do better than perfect. Okay? So, in fact, I could say, hey, make a 5 degree equation. Can you guess what it's going to say if I try to do a 5 degree equation? There you go. It just puts zeros in front of it again. It's saying the best you can do is this cubic. So I'm going to go back to the cubic. All right. So here's the cubic. So let's answer the rest of the questions that were asked in the problem. So I'm flipping back to the actual question here. So the first part of the problem was just giving us all the data, and we've already entered that in, and we made our scatter plot. So the first question said, find a regression function which best fits this data. Well, we did. It was that cubic. Then it said, use this function as a mathematical model to predict the most number of customers she could have at her store in a given month. So what's the most number of customers that we could get? So flipping back to this graph here, so remember the amount of customers you can get, that's the y-axis. So asking for the most number of customers you can get is basically asking for where's the highest y-coordinate here. Now when you're doing your calculus, you can do a trace. We also saw how to use the maximum command and the minimum command on the calculator. But let me show you in GeoGebra how you can find this high point. Now it turns out the command to find the high point will also at the same time find the low point, which looks like it's down there. So here's the command to do it. So you go to the input window right here. I'm going to click there. And the command's kind of a funny word. It's the word extremum. So let me spell it for you. E-X-T-R-E-M-U-M. Extremum. And by the way, when you start typing, it also gives you like a little help feature with a little tab. So it tells you, here's the command you're starting to spell out. So extremum is what we want. And you put parentheses. And you have to tell it what is the function you want to find the extremum of. So it called this function f. So we want to find the extremum of f. So we're going to type in f there. So that's just what the name of this function was. The name of our cubic is called f. So we type in extremum f, and we just push enter. And if you'll notice, 2 new points appeared. There's a point down here called a, and over on the side here with the algebra window, it tells you a is at the coordinates negative 3.09, comma, negative 21.68. And it turns out that represents the relative minimum. That's like the vertex of this cubic down here. And then up here, we've got this capital B point, and it's telling us here's the coordinates of the B point, and that represents your relative max. If we had done a parabola, there would have, actually I'm going to switch to a parabola really fast. I'm going to change this from degree 3 to degree 2. And notice there's no B this time. There's only an A point, and it's putting it right at the vertex there. Right? But it turns out we're doing a cubic, so there's actually 2 extrema, 1 local minimum and 1 local maximum. So, all right. Fortunately, the word March here is kind of covering that up. So I'm going to grab that March word, make a little more space there, just so you don't think the March is part of the B point. So we can actually do better than our March showing. So when we did March, remember, that was when we had 40 minutes of commercial time that month and 2,410 customers, but it looks like we can do better. Looks like we can do better. So remember the question said, what's the most number of customers you could ever have? So this is the high point of our curve, B, and if you look at that, the y-coordinate, which represents the number of customers, 2,441.68. So that's saying according to this mathematical model, that's the most number of customers we could ever have. Going back to our question here, it said, also recommend to the store owner how many minutes she should air next month in order to achieve that highest number of customers. So going back to our graph here, so remember this is the high point B, so the coordinates of B, so it looks like it lines up with a little bit more than 40 because March was exactly at 40. And in fact, if you check the coordinates over here on the side, it tells you 43.09, that's how much across on the x-axis, and the x-axis represents our commercial time. So what this is saying is, if we aired 43.09 minutes, incidentally I should point out, the 43.09 minutes, that does not mean 43 minutes and 9 seconds. The units are all in minutes. So that's 43 minutes and 0.09 minutes. So 0.09 minutes, that's like a little bit more than 5 seconds, right? The way I did that in my head is I know that 0.09 is a little bit less than 0.1, which is a tenth, and I know that a minute is 60 seconds, so a tenth of a minute would be a tenth of 60 seconds. So if this had been 43.1, that would have been 6 seconds, but it's not quite 0.1, it's 0.09, so it's like 5 point something seconds. I don't know exactly, but basically 43 minutes and a little more than 5 seconds. If we put that much commercial time on the air, we should achieve a maximum of 2,441.68 customers. Now, how do you have 0.68 customers? You know, does that mean they stick their arm and leg in the store, but not their head? I mean, what exactly does that mean? Well, if you go back to the original question, it said right after it asked us how much commercial time should we air, which was the 43 minutes and 5 seconds, it says, in what way is the value predicted by our model for the highest number of customers not perfectly accurate? Well, it's not perfectly accurate because in an actual graph, it's not just integers. You're getting fractions, right? This graph is a nice, smooth curve. It's not just separate, discrete dots representing whole numbers, right? So to get every single real number on here, you're going to generate like all kinds of decimals numbers of customers as you go through. So, and in reality, you don't have decimal number of customers. So what I would tell the store owner is, well, you're going to get around 2,442 customers, okay? So about that. The decimals don't really make sense in the real world context of this problem. So it's just a mathematical function, which just so happens it has decimals and stuff in it. So these equations are going to have decimals. So sometimes your maximums, your minimums are going to have decimal values, even though decimal values don't really make sense in the problem. And there was still one other part to the problem, because the very last end says, do you think this function still models the real world well when the number of commercial minutes gets large, say over 70 minutes per month? Why or why not? So does our model, our mathematical equation that the computer came up with, does anything funky happen when the numbers get big? Let's go back to the graph. And indeed you can see that, now I didn't go up to 70 here, but after like 65 or so, it starts dipping below the x-axis. So what in the world would that mean if we were talking about, you know, in the context of our situation? In fact, I'm going to shrink this graph a little bit more so we can kind of see what's going on here. Maybe lift it all up. So you can see, after this crossing part right here, after this root, you're starting getting negative y values. So what that would be saying is that if you aired so many minutes of commercial time, suddenly you're getting negative amount of customers. Now, I don't think that really makes sense in real life, right? I mean, what would negative customers mean? So it doesn't really make sense. So the answer is no, this model really doesn't work when the number of minutes starts getting large, because it starts predicting negative numbers of customers, which doesn't really make any sense. I should also point out, you can also have negative x's according to this function, right? And again, this side of the graph doesn't really mathematically make any sense, because it's saying, how would you air negative 20 minutes of commercial time? And you'd also still have customers for that, but I don't know what that means to have a negative amount of commercial time. So put the graph back the way it was. So I'm just hitting Control-Z to move things back. So yeah, so the answer to that question is no, it doesn't really make sense, except in the range of values that we have data for. There it's going to have pretty good predictions. But if we go outside the domain of the data that we have, if we get smaller than 10 or bigger than 60, the numbers really don't make sense anymore. And so lastly, if I were typing up an answer, so don't forget that if the question is in complete sentences, that means you need to answer in a complete sentence. So I would answer something like this. According to Geogebra, the cubic function negative 0.05x cubed plus 3x squared plus 20x plus 10 matches the given data perfectly. And if this was like a big formal report, you could even sketch me a graph or include a screenshot, something like that. Maybe even verify that when you plug in the particular points that you actually get the desired result. And then let's also answer the rest of the question there. It says we would recommend that the owner air 43.09 minutes of commercials in order to achieve, oops, misspelled achieve, in order to achieve the most number of customers for the month, which would be about 2,442. I'm kind of rounding there because it was 0.68, so I rounded up. Alright, so this video has actually already gone on a little bit longer than I anticipated, but hopefully that makes sense about how you could use GeoGebra or your calculator to answer these kind of questions, these regression questions where you make predictions. You would also go on, and if this was actually the question, you would also answer the accuracy questions about what are the range of the values where it starts to fall apart for our model. But we've already sort of answered those verbally, and I could go ahead and answer that as well, but I'm kind of out of time. It's already gone half an hour. So if you have any further questions, please feel free to ask me in class. Thank you, and good luck.